Thank you for joining us. I'm Rhonda Miller with Utah State University. Now, you may be wondering why we're interested in the impact of cover crops on nutrient leaching. Well, that's primarily because Utah is one of the lowest adopters of soil health practices in the nation. We rank 42nd in the number of acres of cover crops planted. Now, much of that has to do with our cropping system and just the number of crop acres that we have, but a lot of it is that our producers haven't adopted those soil health practices, especially cover crops. And that's because they don't really think they're going to work. When we look at the other soil types of soil health practices, only 14% report that they use some form of conservation tillage. That's according to the National Ag Statistics Service. Most of those that do say they use some conservation tillage, it's not no-till. It might be some form of reduced tillage, but it's not, there's very little no-till actually being utilized in our state. Now, some of this has to do with our cropping system. One of the primary cropping systems is alfalfa. Alfalfa is a very big crop for us, followed by corn, silage, and wheat, just to help break up the cycle, the pest cycles. And and so then when we look at that in our soil health practices, we are returning very little residue back to that soil. Alfalfa, you're cutting off all the vegetation. You have the living roots. Those are good, but little vegetation. Corn silage, we're again harvesting all of the vegetation. And then wheat, they harvest the grain, and then they come back and they harvest the straw. So year after year after year, we're basically taking off all of the vegetation, and very little crop residue is being returned to the soil. When we look at our dry land, it's oftentimes a wheat fallow rotation. Those yields are very, very low. So even though they leave the residue there, there's just so little residue produced that it's not returning much to that soil. So our soil health practices are probably not the greatest. And so we are working on trying to improve the soil health adoption and improve our soil in the state of Utah. We have a group, this Utah Soil Health Partnership Coalition. It's our conservation districts, the Department of Ag and Food, the Division of Water Quality, NRCS Extension, some of our farmers and ranchers in the ag industry, and we're actively trying to promote soil health and regenerative agriculture principles and practices. We have been working hard at this for probably about the last 7 to 10 years, and although we've been able to generate considerable interest, our adoption rate has been very, very low. And part of that is because our producers are skeptical that it can work in Utah or in the Intermountain West. There's a lot of research showing that it works well in the Midwest or further east, but the Intermountain West is a different animal. We tend to have alkaline soils, not acidic soils. We tend to have very short growing seasons, especially in like northern Utah with the high elevation. And then our water is another issue. We're a very dry state by nature. And so if we have irrigation water, the availability of that water can be very limited. The canal company decides when that water can start and is put into the canals, and they determine when it ends. And so in northern Utah, Labor Day is typically a very common time to end the water in the canal. So even if we have a longer fall or warmer fall than normal, we won't oftentimes have the water available to help a cover crop establish or grow well. And so it becomes difficult to get much growth on our cover crop if we don't have that water availability or that longer season. And we do get some very early frosts, so our growing season can be very, very short. So basically, our producers are going alkaline soil, short growing season, limited water availability, and they're just very, very skeptical that it can work. So we are doing this. We've gotten a NRCS Conservation Innovation Grant, and we are doing a study where we have 17 fields, farms across the state representing 7 major cropping systems, and we are having those producers use their traditional practice, what they're using now, and they may have some conservation practices implemented into that, and then adding another soil health practice. And they get to choose what additional soil health practice they're using. And then we're comparing those two systems in their fields on those farms. We have is this project is being led by our Department of Ag and Food with a lot of scientists from Utah State participating in this. Some of the other things that we're doing with this is we're working on building a support network to help mentor other producers. We're doing surveys to help identify barriers to the soil health practice adoption. We have economists looking at the economics of it because that's the bottom line. Everything needs to be make some sense economically. They can't just be a cost. And we're also looking at the environmental assessment, the water quality part of it. And I'm doing that part. And that's what I'll report on today. We, of course, have scientists looking at the key soil health indicators. These are some of the key ones. Are doing all of the ones NRCS ones, with such as soil organic carbon, aggregate stability, bulk density, water holding capacity, etc. And we're looking at nutrient leaching. I'm doing that just at two locations due to the logistics and the expense of doing the leachate studies. Both of these are in northern Utah near Lewiston, and we have two farms. They they both have a Lewiston or a Kidman fine sandy loam soil, so it's very sandy, and both of these producers apply manure to their soil. Now, the reason we're interested in this is that we know that nutrients are our biggest source of pollution from agriculture, and we know that our soils can help affect that. If we have a good nutrient holding capacity in the soil, we can improve or reduce the nutrient leaching that we have. In this case, those soils are both very sandy. We inherently have a low organic matter percentage in our soil anyway, and a sandy soil tends to hold even fewer nutrients, so nutrient leaching in these soils is very likely. When we look at the leachate, our water table is only 30 to 60 inches below the soil surface, so we are very interested in protecting our groundwater table. We have, and we also don't want to have runoff and things. We have many pristine water sources and a lot of trout in some of our waterways, and so we're trying to help protect those. We do also realize and acknowledge that nutrients can volatilize. That is not part of this study. We are not looking at that component. Now, one of the biggest reasons we're concerned, or our producers are concerned, is the economics. That if we're losing nutrients to leaching, we are basically they're going to have to either replace those and buy more fertilizer, or they may end up with some yield loss, or we're going to end up with some environmental impacts. And when we look at the environmental impacts, it might be air quality. We do have problems with PM 2.5 in Utah, especially in the winter months with the inversions. And we're very concerned about the water quality. Again, we have some very pristine water sources, and we would like to maintain those. Now, you all know eutrophication is one of our biggest issues when we have nutrients in our water sources, the algae growth, and fish kills, but we are seeing a lot of harmful algal blooms in Utah, and that seems to be increasing. It's impacting a lot of our reservoirs and recreational areas, which is a concern to the public, but we're also finding some livestock deaths and other results of those harmful algal blooms. So that's, and we know agriculture is a contributor to that, and we are trying to find ways to help reduce that potential. And if our water, those nutrients get into our groundwater, we know that that can lead to blue baby syndrome, spontaneous abortions in livestock, and more troubling is the childhood cancers, brain cancer, and neurological cancers, and that's heartbreaking. So I'm just going to pick on Nebraska, my home state, but if no state is immune. When we look at Nebraska, this is a map. All those red dots are wells that have been tested that exceed the EPA drinking water standard. Now you can see that there's, like along the Platte River, where there's higher nitrates, not necessarily to be unexpected. Some of those little bit higher cropping areas, but even out in the sandhills where there are very few people, very little intense cropping, and we are seeing red dots, wells that exceed the drinking water standard. Nebraska is not the only state. California has a huge issue in the San Joaquin Valley where they have been applying primarily too much manure for a long time, and their groundwater is now contaminated, exceeds the drinking water standard, and they know that they have still, even if they stopped adding any more nitrates or prevented any nitrates from coming down, they still have about a 40-year train of nutrients that are going to make their way down to that groundwater table. And that's and Utah and California and Nebraska, we're not the only ones. There are many, many states. It's becoming a bigger issue around the nation. So to monitor or that leachate and how much leaching we're getting, we are using what's called a modified zero tension lysimeter. So I've done ones before where we took a 15-inch diameter by 44-inch tall soil core, put it on top of a collection system, and buried it back into the soil in place. For this one, we aren't doing the actual soil core, but we took an auger, we took the soil out in layers and kept track of it so we could put that soil back in the order, the right order. And our lysimeters this time are a little bit smaller. It's a 12-inch diameter lysimeter at the top with a reducer. There's a collection system. And then at the bottom, we have PEX tubing that we then bury out to the end of the field. So whoops. We come in, dig our hole. We have the top of that lysimeter being at least 3 feet from the soil surface. Most of them are probably closer to 3.5 feet. And we then take that PEX tubing and bury it in a trench out to the edge of the field. So here's where we had marked that we installed our lysimeters. We had two of them meet. We trenched out to the edge of the field. There's where we're trenching. And then we have that PEX tubing come up on the edge of the field, out of the way for the producer. And we have it coming up inside a regular irrigation box, a landscape irrigation box. And then we have a metal plate that we put over top of that so that if vehicles or livestock go across it, that there's not a chance that it's going to punch through. The PEX tubing was buried 30 inches deep out to the field so our producers can plant and till over it. And the bigger ones that I had with the soil cores, those have been in place for 22 years. We had to finally abandon the farm, that location, but the lysimeters were still working great. We'd planted and tilled over them many, many times. In this study, our producers were using deep ripping and chisel plowing and testing them out right away, and they held up. They're buried deep enough, and all of the PEX tubing and stuff is where it comes up is outside of the field itself. The leachate we collect biweekly. Typically, we start as early as we can in the spring. We go till as late as we can in the fall. That's typically around Thanksgiving time. And then we just get too much snow. We really can't get out there. But we have a collection system, so we're not losing any of that data. And then we come out with a pickup and a generator and a vacuum pump. We connect our carboys to the PEX tubing and let that vacuum pump away. It can be kind of like watching paint dry. It's not super fast, not super slow, but it's kind of slow watching the last little bits of that leachate come in. And then we measure the amount of leachate that we collected and we keep a sample for analysis. And we go and do this basically every 2 weeks. Now, when we installed these lysimeters, that was in the spring of 2023, probably the worst time possible that we could have installed these lysimeters. It ended up being a very cold, wet, late spring, and our producers were chomping at the bits. They were just dying to get out into the field. And we're trying to get like these lysimeters installed before they planted. It was a race against time. One of our producers in this study was in a super big hurry and trying to get his manure applied to his field. And so you can see he was applying manure when it was very, very wet, and he's leaving some very big ruts with that manure. And so as I was looking at that and thinking about all the compaction that we're going to be seeing from that, we ended up adding in taking soil samples down to a depth of 5 feet. We already had soil samples being taken to a depth of 1 feet with all of the soil tests and things, but we're taking some deep soil cores so that we can watch and monitor the nutrients as they move through that soil profile. And at 5 feet, there we should be well into that groundwater table. So now our producers, the first year, they both planted corn and were interseeded a cover crop. The cover crops that our producers tend to utilize is some grass, either rye or oats. They'll typically add a legume, clover, and or vetch. In this case, our producers had both of those. And they'll typically have a brassica in there. And the most common one is radish. Now, to make this work, or cover crops work in Utah, what we've found seems to work, that works pretty well, is if we can interseed those cover crops at the V5 stage for the corn. There's a narrow little window, so pretty much between V4 and V6, that's our window to get our cover crops established. And what we're trying to do is we want the corn to be established so that the cover crops don't compete with it, but then we want to get those cover crops established before the canopy covers that soil row so that they're established so that once the corn is harvested, the cover crops are there and then they can take off very rapidly. When we start to look at the results of this and what we saw, what we're seeing is that when we look at the conventional to the soil health practice, for the volume per lysimeter in both cases in 23 and 24, the conventional system, their conventional system, had produced more leachate than the soil health practice system. Not unexpected. The cover crops can help absorb or utilize more of the moisture. That's a good thing in our world because we have not that much extra water and we are trying to utilize every bit that we can and conserve what we can. In 24, so in 23, our producers both had corn with the cover crops. In 24, Gerald put in, was switching over to alfalfa. So he planted oats then, and then in the fall of 24, he planted an alfalfa crop. Joe is still planted corn. He was planning to interseed his cover crop and missed that window. And so the 24 data that we have for Joe does not reflect having that cover crop in it. When we look at the nitrate concentration per lysimeter, the average nitrate concentration is reduced with the soil health practice in both 23 and 24. Oops. And again, it was for Joe's also in 23. The 24 one, again, he didn't have a cover crop. So that one there's not a cover crop to evaluate on that one. And this is the one that we really want, the total nitrate per lysimeter. Again, our conventional system produced a lot more nitrate leaching than the soil health system in both years and for both producers in 23, Gerald for 24, and in Joe for 24, there wasn't a cover crop to impact it. So this is when we combining the results from both producers for 2023, where they both had corn with a cover crop. And what we see is that there is reduced leachate production with the soil health, our cover crop, not to be unexpected. The concentration, the nitrate concentration on our leachate is reduced in the soil health system. And the total nitrate that's lost per lysimeter is almost double in the conventional system than the soil health system. That's a great start. If we can cut the nitrates that we're losing by about half, that's fantastic. And so we have another couple years to go, so we'll see what we get in those years. But so far, it's looking very promising that our cover crops can reduce our nitrate leaching, even in our sandy soils with very little organic matter. What we are concluding so far is that our short growing season really needs to have the cover crops established earlier. We've had very poor success trying to establish cover crops after we cut the corn silage. So interseeding at that V5 stage is pretty critical. The drawback to it is that there's a very narrow window for cover crop establishment, and so you have to really be on top of that. But we are seeing good reduction in nitrogen leaching with our cover crops in our slightly modified system by interseeding at the V5 stage. And I would like to acknowledge the NRCS and the CIG grant that we received to help fund this study. And we have 3 more years to go. And with that, I'd like to thank you for your time.